as we go on to topic 2 of module 4. And again, our other old lesson number designation is right up here. We're going to be dealing with rational numbers as exponents. This is sometimes referred to as fractional exponents. And we'll be reviewing these topics. So let's go on. Now, I've left in our new format here room over on the left where I'm going to ask you to carefully copy these examples down on the left side of your page, and I'll write them big so you can see them, and I'll do it too. Want to give you some background also up over here. When we see the radical expression, we have here this sign. This is called the radical sign. Now, there's a notch in the radical sign, and what we put in there, as we mentioned before, this is called the index number. So we'll just put like an N there for the index number. And what is under the radical sign here, this is called the radicand. Okay, so we have the index number, the radical sign, the radicand. Now, a typical way that you might see this is this example that I have here, where the index number is a 3, the radicand is an 8 to the second power. Now, another way you sometimes see this is, again, the index number is 3, you have the radical sign, you have the radicand 8, and the exponent of that 8, where here it's close to the 8, could be in a parentheses outside, as we have it here. So, this is something to keep in mind. Now, what we're going to do as we write equivalent expressions using radical notation, and if possible, simplify, we have these expressions in what we call fractional exponential notation. Now, there's a little pattern to it. In fact, let's just do this one first. There's our base now. We take our index number, and that makes the denominator of our exponential fraction, and the numerator is the exponent that we see there. So 8 to the 2/3 power, this would be an exponential fractional notation, and this is its radical form using the radical sign. So these two things are equivalent. So let's just spend some time and notice that instead of writing the fractions in this funny way here, I put it clearly with my division bar horizontal. So this is going to be our index number of 5, radical sign, a negative 32, and our exponent, since it's a 1, we don't write it, but it would be a 1 there. Now they're asking to simplify if possible. What is the fifth root of a negative 32? A negative 2. Now, 2 to the fifth is 32. But since it's an odd index number, we are allowed to have a negative under the radical sign. All right, this one, again, we're going to set up a radical sign. And since this is the first, we don't need to put this in parentheses. P, Q, R. We take our denominator of our fractional exponent, and that becomes the index number. Now, the 1/2 power is actually just the square root sign, because this is our index number that we don't write. And it becomes then 49 a to the 8th. Now, the square root of 49 is 7. And again, if we just multiply this, we get 8 over 2, which is a to the 4th power. Remember, we can do the multiplication here too, and just take the square root of that. So this is our answer. Now for this one, we want to go 4th root of 81, and this whole thing will be to the 3rd power. Remember, it's the denominator of our fractional exponent that is the index number. Now, 81 is a perfect 4th, so how many times, or what is the factor there? 3. 3 to the 4th is 81. So we end up with 3 to the 3rd. There's our exponent, and that's 27. And here all we do is just multiply our exponent by the power, which is 1/5. So this becomes a to the 4/5. This becomes b to the 3/5. But I don't think they wanted that. They wanted us to put it in radical form. So we can just go radical sign, 5th root, and since it's to the 1st, all we do is write this here. I got a little carried away on that one. All right, now for this one, again, anytime we see a denominator of 2, that indicates it's the square root of 64 raised to this 3rd power. And again, we don't write the 2 there. Now that will be 8 to the 3rd power, and I didn't need parentheses there. And that's 512. Okay, there's example 1. We've given you some background. There is a relationship between radical expressions and exponential fractional notation. These are equivalent. The denominator becomes the index number. The numerator is the power to which we raise something. And I guess we have some others now, G through M. For this next part, they want us to write these radical expressions into exponential fractional notation. And often, to keep our radicand together, we can think of it something like that. And that's to the first power. Now here, this is to the third already, so we can think of it this way. And this way. And this way. Okay. So, basically all we're doing then is taking our radicand and then putting it in parentheses, using this for a denominator of our fraction, and the 1 is our numerator. So in parentheses, 5 x, y, z to the 1/4. And here, let's see, I didn't leave myself a lot of room. I'm going to need a b to the 4th over 7 in parentheses. My fraction is 1 for the numerator, and my index number is 7. This is an easy one. In parentheses, 6y to the 1/2. Again, there's a 2 there that we don't write, and there's a 1 there that we haven't written. And then here it'll be 11 to the 3/5. And here there's a 2 that's not there, so this will be 3mn 7/2. And this is 2xy over z in parentheses, and then that's a 5/4. Now these answers are there at the bottom of your paper, and you can check them out, but this is the strategy of how to get it done. Okay, let's go on to our last one here. Now, for letter M, they're asking us to round this to the nearest thousandths, and we're going to use our calculator for this. But how do I put that into a calculator? Well, I would use a parenthesis, and I'd put a -19, whatever technique you use to do that. And then what will your exponent be? Well, we use a caret, and I put that in parentheses also. And it's 5 divided by 3. And then you just hit enter. And you get approximately 135.287. Now, if you are doing this and not getting that, then you have to be checking out what you're doing wrong. Again, it's a caret sign. Then you just put in the fractional exponent in parentheses, 5 divided by 3, parenthesis, enter, and actually I forgot to put the negative sign there. There we go. It's a negative that. And that's okay. Because odd root, you can have a negative under the radical sign. Okay, well, let's get on now to number 2. Write an equivalent expression with positive exponents. Well, we can just write these out like we have been doing so you could see them better. Well, rules that we had mentioned earlier, pretty straightforward. we have a negative exponent, all we need to do is take that negative exponent and its base into the denominator, to the 3/7. So just taking it, remember there's a 1 there, so that stays in the numerator, but this base goes to the denominator and the sign of the exponent changes. So for this one, we're going to get 1 over 27 to the 4/3. And they want us to simplify this too. So this becomes 1 over the cube root of 27 raised to the 4th power, which is, the cube root of 27 is 3, and 3 to the 4th power is 81. So that is the scenario of this one, getting it positive, taking the cube root of 27, and then raising the 3 that you get out of here to the 4th power. Now, this is a little tricky, and if you could remember this, it's a good tool. When you have a fraction that is to a negative exponent, to make it a positive exponent, you just use the reciprocal of the fraction, which is 13d over 5c, and then this becomes positive. Now remember, you don't flip this, you just flip your, in a sense, a base here. Take the reciprocal of it, and the fractional or the regular exponent becomes positive. Let's go on. Now the rules for exponents hold. Here when we're multiplying, we just add our exponents. So this is going to be 5. Add our exponents. The denominators are okay. So 4 over 4, which is a 1. So this just is 5. Now here we want to keep our exponents positive. Remember there's a 1 over there, so we're going to bring this down to our denominator. But in order to work with fractions, I have to convert this 1/3 by multiplying each by 2. So this becomes 2/6. So this is x to the 5/6 minus 2/6. As I converted that, I bring it down, the sign changes, and this now becomes x over 3/6, and I reduce the 3/6 to 1/2. And that's the answer. And then here, since we're raising a power to a power, we're just going to multiply our exponents. So this is x. Now notice the 2's will cancel out, so this becomes 1/5. This 2 will cancel with this 2. We get 1/5. And this is why nothing cancels, but it's negative. 2 times 2 is 4. 3 times 5 is 15. And then we write it with positive exponents. So this will equal x to the 1/5 over y in the denominator to the 4/15. And again, if you have a question, be sure you're asking your question. Now, in these next few, we're using rational exponents to simplify, but do not use exponents that are fractions in the final answers. That was cut off there a little bit. So, as we convert this, this is going to be 7z to the 4/6. The 4/6 reduces to 2/3. So now putting that back into radical form, it would be the third root. That would be our denominator that becomes our index number, 7z to the second. So in a sense, all we had to do is take the 6, put it under the 4, get the 2/3, and then put it back into its form. We're simplifying this fraction. And the same thing here. 4 will go under the 20, so this just becomes a 5. So we have then s to the third, t to the second, that we're raising to the 5th power. So this becomes s to the 15th, t to the 10th. So again, I took the index number, put it underneath the numerator, which was the exponent, simplified that, got this base now to the 5th power, did my multiplication, and I simplified. C looks a little daunting, but not too bad. So let's work from the innermost. So this is going to be a to the 1/3, because there's a 1 there, a to the 1/3. Put that in parentheses. And then this is to the 1/4. Again, there's a 1 out there, sort of. And now we just multiply that, and we get a to the 1/12. And they don't want fractions. They want it back in its radical form. So it's the 12th root of a to the 1st, but we don't write that one. Okay, you'll have some practice, and you'll quiz me as you start to work with fractional exponential form and converting into our radical form. And we were just over 23 minutes, not too bad.